All right, ready for a deep dive into something pretty cool. Snowflakes. You might think you know them, but we're going to unpack some amazing chemistry facts about these little frozen wonders.
They're a lot more complex than people realize, yeah.
Facts that are going to make you the hit of your next winter party, by the way.
Exactly. It's fascinating how much science is packed into something so, well, seemingly simple.
So let's break it down. We all know snowflakes are ice, right? But what else is going on in there?
Well, it's more than just ice. Air plays a big role. Think of a snowflake like it's a structure, all these ice crystals, but with tiny pockets of air trapped inside.
So it's like a frozen froth.
Kind of, yeah. And that mix of ice and air, that's what determines how dense the snow is.
I never thought about the air inside a snowflake before.
It's easy to miss, but it matters. The density of snow, that affects everything. Insulation, even avalanche prediction. Like a denser snowpack, that means less air, and that can change a lot for the environment.
Okay, makes sense. But how do those ice crystals even form in the first place? Is it just water freezing?
More complex than that. We got to go down to the molecular level. Water molecules, they've got this unique thing, hydrogen bonds. That's how they arrange themselves into those cool hexagonal lattices.
Hold up, hexagonal lattices. That sounds pretty technical.
It's simpler than it sounds. Just picture the classic six-sided snowflakes, like on holiday decorations. That shape comes directly from those water molecules bonding together in this hexagonal pattern.
So the shape of a snowflake, it's literally from how the water molecules are arranged.
Exactly. And it gets even cooler. You know the saying, no two snowflakes are alike? It's true. The temperature, the humidity, all that stuff during crystal formation, that influences the tiny, unique details of each snowflake's shape.
So it's like each one has its own fingerprint based on the conditions it formed under.
Exactly. Scientists are still figuring out all the ways those factors work together to create that huge variety we see, like a tiny, delicate sculpture shaped by invisible forces.
That's wild. I always thought they were just randomly shaped.
There's so much more to it. And that air we talked about, that plays a role in the snowpack too, how much air is trapped inside. That affects the density, and a denser snowpack, well, it acts like a thick winter coat for the ground.
So a fluffy snowdrift, that'd be less dense, and a packed down snowpath would be denser.
Precisely. And that density, it's crucial for insulation. A denser snowpack helps protect plants and animals from those freezing winter temperatures, nature's way of providing warmth.
This is making me see snow in a whole new way. So much science going on.
Always more to learn, even about something as familiar as snow. And speaking of learning, this next point brings in something called albedo.
Albedo, I've heard that before, but can't quite place it.
It's all about reflectivity. Snow, being white, bounces a lot of sunlight back into space. That's albedo. And it actually plays a big part in regulating the Earth's temperature.
So snow's like a giant mirror, reflecting the sun's energy back out.
You could think of it that way, yeah. And that reflecting is important for our climate. Changes in snow cover, especially because of things like climate change that can have effects on the whole planet.
Incredible. Something as simple as snow can impact the planet's climate that much.
It's all connected. Shows how amazing and complex nature really is.
This deep dive's already blowing my mind. And we're just getting started.
Ready to dive deeper into those unique snowflake shapes?
Yeah, definitely. We talked about temperature and humidity playing a role, but I want to know how.
Okay, so picture this. A tiny ice crystal way up high in the clouds.
Got it.
As it falls, it goes through different layers of air. Each one has its own temperature, its own humidity.
So the snowflakes on this journey, its shape is changing based on, like, the air it travels through.
Exactly. Say it goes through some colder air.
Okay.
Those water molecules, they freeze onto the crystal faster. That's what makes those intricate branches, the stellar dendrites we see.
So colder means faster growth, more complex shapes.
Generally, yeah. But then imagine it hits a spot with more humidity. Things slow down. That moist environment, it makes simpler structures, like plates or columns.
So it's this balanced temperature and humidity shaping these wild patterns.
Right. And those conditions, they're always changing. Even tiny little changes make a difference. That's why each snowflake is unique, its own story in the ice.
That's so cool. I thought those designs were just random, but there's this whole science behind them.
And that science, it goes beyond just looking pretty. Remember snowpack density? How well it insulates? The snowflake shape matters there too.
Really? How so?
Okay, think about those branched snowflakes, the dendrites. They're kind of like, branches. They don't pack together tightly. More air trapped between them. That means a less dense snowpack.
So a fluffy snowflake makes for a fluffy snowdrift.
You got it. But those simpler shapes, plates, or columns, they pack in tighter, denser snowpack.
So the shape affects how dense the snow is, which then changes how well it insulates the ground underneath it? It's all connected.
It is. It's a chain reaction. And it all starts with those tiny water molecules and the forces that shape them into those amazing structures.
This is making me see snow so differently. It's not just about pretty patterns. It's like Physics and chemistry shaping the whole winter landscape.
And that landscape affects the planet's climate, too. Remember albedo, how snow reflects sunlight? There's more to that.
Okay, what else about albedo?
It's not just the amount of snow, it's the type, too. Like we talked about different snowflake shapes, they make different snowpack densities. And that density, well, that affects the albedo.
So a denser snowpack with those tightly packed snowflakes would reflect more sunlight than a fluffy one.
Exactly. Denser pack, it's like a smoother mirror. More sunlight bounces back to space. But a fluffy one, more air pockets that absorbs more sunlight. Less reflection.
Wow, so the shape of the snowflake actually changes how much sunlight the Earth absorbs. That's incredible.
Right, and this matters big time for climate change. Temperatures go up, snow melts earlier. That changes the albedo, which can make the warming even worse. It's this whole feedback loop.
This is really showing how everything in nature is connected. I never thought something as small as a snowflake could have such a huge impact on the planet's climate.
It's a good reminder, even the smallest things can be important. That's what makes science so cool. Always more to learn, even from a single snowflake.
You know what? This whole deep dive has really changed how I see snowflakes.
Yeah.
I used to think they were just pretty falling snow, but now it's like I see these mini science marvels everywhere.
It is amazing, right? How much is packed into something so simple looking? And honestly, we've only scratched the surface of snowflake science.
I know. You mentioned researchers are still figuring stuff out. Like, what are they working on right now? The really exciting stuff.
Well, one big thing is how snowflakes form in different conditions. Like up in the atmosphere, it's not all the same, right?
Makes sense.
Scientists, they're using these high-tech instruments to basically recreate those conditions in the lab. They can control temperature, humidity, even the tiny particles floating around.
So they're like snowflake detectives, building them in a controlled environment.
Exactly, and by doing that, they learn how those factors affect the ice crystals, how fast they grow, what shapes they take.
So what they can tell us about weather patterns by making snowflakes in the lab.
It helps, yeah. And not just weather, even stuff like climate change. There's even some thinking it could teach us about how planets form in other solar systems.
Wow, that's a big leap from a tiny snowflake.
It is, but it shows science is all about these connections. Even the smallest things, they have these huge impacts we don't always see.
This whole deep dive has been eye-opening. I feel like I get the beauty and the complexity of nature way better now.
That's what it's all about, right? Getting people curious, showing them how amazing the world is, and maybe making them want to look at things with a little bit of that scientific lens.
Well, mission accomplished, I'd say. I'm about ready to spread the snowflake gospel now.
That's the spirit. And hey, I remember, next time you see snowflakes falling, take a second. Think about the journey it's been on, all that science shaping it, the impact it has on our planet. It's pretty remarkable stuff.
I will. Thanks for taking me on this incredible deep dive into snowflake science.
Happy to do it. Stay curious out there.